Hello, today we will be solving problems on determining the empirical molecular formula, but this task is a little different from those we have solved with you before. According to the conditions of our tasks, we know the mass of the elements that are part of each of these formulas, and accordingly, the question is to find the empirical formula. So, let's recall how such problems are solved. So, in the first problem, the elements present in this formula are magnesium and oxygen. What is their known mass? For magnesium, it is 2 and 4 grams, and for oxygen, it is 1 and 6 grams. What should we do next? We need to determine the number of moles of each of these elements. Then, for this, we will divide the given mass by the molar mass of the element, or that, which we also refer to differently in relation to atomic mass, but expressed in grams per mole. Then it turns out we divide for magnesium by 24 grams per mole, and that gives us 0.1. For oxygen, it will be 1.6 grams relative to 16 grams per mole, and this will also be 0.1. So we have the ratio between moles in this case, meaning this value in moles we can note here, so it will be 0.1 to 0.1, or it turns out to be 1 to 1, which means our simplest formula will be magneo. But I would add that the magneo formula in this case will not only be an empirical formula, this formula will also be molecular. Why is that? Because this compound cannot have a different formula. It cannot be doubled or multiplied by a larger number accordingly. Therefore, this formula is both the simplest empirical and molecular formula. Thus, we solve the second problem by analogy. So, which elements are presented here? Sodium, sulfur, and oxygen. So, for sodium, we have a mass of 9.2 grams, and for sulfur, we have 6.4 grams. For oxygen, 12.8 grams. We do exactly the same for sodium, 9.2 grams. We divide by its mass of 23 grams per mole. This will be 0.4 in moles. So now sulfur will be 6 and 4 grams divided by 32 grams per mole. This will be 0.2 moles. And for oxygen, it will be 12.8 grams per 16 grams per mole. In this case, the value will be equal to 0.8 moles. All right, now let's derive our simplest formula using the mole ratio 0.4 to 0.2 to 0.8. But to find the least common multiple, we will choose the smallest value, which is 0.2, and divide all the numbers by it. Then we get 2, 1, and 4, and consequently, our simplest formula will be 3.2. Na2SO4 is called sodium sulfate, and this formula is derived empirically. But I will add that this formula will be final and molecular because this formula cannot be doubled, tripled, and so on. That is, in such tasks, the simplest formula is not always obtained, which can then be doubled, tripled, and so on. Sometimes in such problems, the formula turns out to be both empirical and molecular at the same time. These formulas are identical to each other, And since I hope you understand how to solve such problems, you will be able to solve similar ones. It may even be that when there are more elements than in my presented examples, say 4, 5, and so on, such tasks are very popular in organic chemistry. Goodbye.